Hi everybody, my name is Peter van Amsterdam. I'm working for Baker Hughes and we are also a sprint member. As Chibi said, today we are at sprint robotics chapter, and today I'm not going to talk about robotics. We are a robotic builder, but we also have some other solutions. And this solution better fits to the Stock Expo. And today I want to talk about tubs and cups. I'm going to explain what it is. Here I got a little bit of a slide who we are. We are quite a big player. We dig up the oil and bring it to the refinery, and we help the big oil companies with that. I've got some colleagues around the world. But today it's about taps and cups. I think you're familiar with taps. We call it a tank and our plate services. How does it exist? And the other thing we found when we developed this technique is also suitable for cups, and it's called corrosion under pipe supports. If we take a little bit a closer look at the tank and our plate scanner, it's about inspecting the first, let's say, 150, 300 mil underneath the NR plate. And we do this with a technique. It's called a guided wave technique. Now, how does it exist? It is the critical zone in the inner side of the tank, under the inner fillet weld. You have there the critical zone, heated effective zone. Corrosion starts there first. So we have a sensor. It's driven by a robot, and the sensor runs over the chime. And we do it in service. So it's independent of the liquid, what is inside the tank. It's independent of its in service or out service. And we can do it also with quite high temperature. And we do it with a method called guided wave, but it's not the standard guided wave. We sort of tweaked it into a bulk wave sensor, and we call it a higher order mode clusters. So what happens is we send in a bulk of solitary waves who penetrate sort of unhindered to the metal, and we get like a big bulk of waves back, and in a dispersion curve we find a very crystal clear signal, and therefore it's very high accurate in sizing the defect. This is a little bit the specification what we have on this technique. So we scale the defects in bandwidths of 20%, and even if the chime is quite smooth, we can even reduce it to 10% bandwidth. We need a sort of situation, 40 mil chime. We recently started to develop some smaller sensors, so if you have like a 20 mil chime, we can even put it on. But we need a minimum defect of about 1 inch. Otherwise, we can detect the corrosion, but we not really can size the corrosion. The wall thickness of the plate is important, 5 mil. We have up to 70 degrees product. We can use the system, and got a very small dead zone, so almost within the probe length. So if you put the probe on the chime, it's very close to the side of the tank. How does it look like? Here's our robot. We put it on a plate. It's run automatically around the chime. Of course, if you have some pumps or some nozzles, we cannot as, inspect over there, but we can normally do about 80 to 90% of the tank. So that's the technique we use on an annular plate. But we find out that we can put these sensors also on the pipes. And we call this CUPS, corrosion on the pipe supports. And here we see some pictures of corrosion. I think you're all familiar with this problem. And what we notice is that we can detect corrosion and size corrosion already from 2-inch pipes, and it's quite small. And we can size in approximately a bandwidth of 10%, starting with 20 up to 70. And here you need a minimum size defect of a 1/2 inch, depending on if you can put the transducer on 2 sides of the support. And we can do it in 2 different ways. We have the actual scanning, so meaning sending the signal through the length of the pipe. But we can also do circumferential, and then we can suddenly inspect pipe supports or ring supports. Here you can see a little video of an A scan, meaning sending the signal into the pipe. So if you have a ring support, you can inspect these supports. First we do it on one side. To be a little bit more accurate, we do it on both sides. But we can do it also circumferential. That means that we can run the scanner over the pipe. So if you have, for instance, pipe laying on a concrete slab, and you have corrosion on the 6 o'clock position, then we can actually run endlessly the scanner. Here are a little bit similar specifications. At the moment, we use the scanner from 6-inch, but we can do smaller ones as well. And otherwise, we use the A-humps technique. And here you can see the video when it's running over the pipes. We can do up to about 30-35 supports a day, depending a little bit on the situation. Of course, when you are on height or you have a lot of different sizing, then we have to rebuild always the scanner. We have a clear report. We have not only the numbers, but also the pictures from where the defects are found, how the situation is, and the scan. So if you want to pitch our product a little bit in the competition, I think, and we are highly accurate on sizing the defect. We can do very small piping, 2-inch. We can do axial and circumferential scanning, so ring supports are not a problem. We can run unlimited distance. We are unaffected by corroded surfaces. And we also have trunnions and scabbing, what we can do. There is a hoist trial coming up this year. We are participating to get our system qualified. We have clear reporting. So here we have the scabbing. We can do this on live asset. Make sure that you know what is still your remaining wall thickness before you start doing maintenance work on the corrosion. And we have also good results on doing trunnions. So the signal is unaffected by the welded support on the elbow, and therefore we can do trunnions. Any questions? And I think I'm in time.
Hello everyone, this is Mohammed Al from Saudi Aramco. Just I would to discuss with you about one of our challenges with corrosion under pipe support.
Sorry. Can you repeat again the question?
Yeah,
Sorry.
this is Mohammed Al from Saudi Aramco. We have faced a challenge with one of our pipeline, which is a 20-inch pipeline.
Yeah.
It is elevated above the ground, so there is a weir pad every 12 meters. We have found a corrosion between the pipe, the main pipe, and the weir pad itself. So, is there a way to inspect this weir pad and to discover if there is corrosion and quantify the corrosion percentage? So, actually, the pipeline is welded to a weir pad.
Yeah.
The width of the weir pad is 50 centimeter. It is starting from the 4 o'clock position up to the 7 o'clock position.
Yeah, I think I understand you because I cannot hear you.
Yeah, can you hear me now?
Yeah, it's better.
Okay, we have a pipeline, 20-inch pipeline, where it is elevated above the ground, and every 12 meter there is a supporting beam, and there is a welded weir pad to the main pipe. The construction of the weir pad, it is equipped with the weeping hole. It is constructed long time ago, so we have found a corrosion scale between the weir pad and the main pipe itself. So we are trying to inspect this weir pad to identify or quantify the corrosion percentage.
Yeah, if I understand your question right, we can have we use the pitch and catch technique. So we have the sender and the receiver, and we just put it on the pipe. And everything between this sender and receiver will be detected. So we can make like a grid around your pipe and just follow this grid and get all the measurements. And then we can detect the corrosion within this grid.
So can we do the inspection from the top of the pipeline, from the 12 o'clock position, even if the weir pad is welded on the bottom?
Yes, that's correct. The technique is unaffected by welded pads, so it's really just going through the modern material from the pipe, and will detect corrosion on the inside or on the outside of the pipe without detecting the pad. Yeah.
Okay, if you allow me one more question. Even if the corrosion of a scale has developed a dent, this dent can be inspected?
Yeah, that's correct.
Okay, thank you.
All right.